Hello and welcome to this episode of SPSS one-on-one series with the Warrior Analytics. Today we do our final model check. This is the last of a series of episodes that we've been making on linear regression. If this is your first time here, consider checking our previous episodes so that we are on the same page. In the last episode, we checked for confounding, and so we are doing our final model check, then interpret the findings, then report our results for our report. So let's get back to the computer. So in our previous episode, we saw that this is our final model. So we have all our 7 variables have made it to our final model, and we also have 3 interaction terms that were significant, indicating there was interaction between variables in our model. So it is high time we interpret this model and then report the results of this analysis in our report. So what we are interested in, one, we have a model summary here that shows the R and R squared. This R would show is equivalent to the multiple correlations coefficient. If we were running a multiple correlations coefficient, this would be the correlation coefficient. But then we are interested in this R square, which is which shows the amount of variability in our salary that can be explained by the variables that we have analyzed. So this one, 0.866, indicates that 86.6% of the changes in current salary can be explained by the variables that we've included in this model. Okay, so that's very important. The ANOVA table is statistically significant, indicating that these variables are related or associated to the outcome. Then we turn to the coefficients table, which have our basic variables and our interaction term. These are the correlation coefficients. These are our p-values. So within this table, if you were to write this table mathematically, the equation, this is what you would have. Y equals alpha plus beta 1 up to beta 7. That is for our basic variables. Then we have sigma 1, indicating the correlation coefficients corresponding to the interaction terms. Then Z1 up to Z3, the 3 interaction terms, plus the error term. Okay, if we substitute that, we would say that someone whose current salary would be equivalent to 8,376 plus this variable, okay, this coefficient multiplied by the months that person has spent, plus using this constant, multiply it by their previous experience. Like, you can predict someone's current salary based on if you have this information. However, let's look at now how can we report these results in your research. If I would, with these results, you could just write as simple as this: a multiple regression, okay, a multiple linear regression was run to predict the current salary from months since higher. You're mentioning here the variables that you were using to predict current salary. This resulted in a significant model, F. These are degrees of freedom from your ANOVA table. Okay, this is the F statistic. This is the p-value. It was less than 0.001. we saw the R square of 86.6. The individual predictors were examined further and indicated that months since higher, you put the t statistic, it is p-value. Those that were significant, we list them here, and we conclude by saying were significant predictors. However, gender and beginning salary were not. There was significant interaction between, yes, beginning salary, previous experience, and minority classification. We have successfully run our linear regression and presented our results. Right from transforming the variable gender, which was not coded, it was a string variable, to checking assumptions. We checked for outliers, for collinearity. Then we went ahead to build our model, selecting the variables, checking for interaction, checking for confounding. Then from there, we had to go and do the final model check, looking at the R squared, interpreting the coefficients, and then proceeding to presenting our results for our research. So next we are going to look at another type of regression, that is logistic regression in SPSS. Consider liking and subscribing to the channel so that you don't miss out any of our episodes. See you in the next video.